All right. What's up, everybody? This is me, Yawar Manzoor, and I believe everybody of you is doing great, nice, and absolutely fine. Okay. And I welcome you to JEE English Unacademy. And my name is Yawar Manzoor. If you haven't subscribed yet, just do it right now. Understand? Just do it as soon as possible because we come up with so many live sessions every single time, and press that bell notification so that you'll get the update every single time whenever we come live. Okay. And okay. Yes. So, ladies and gentlemen, boys and girls, this is the Fury Live. We are running this Fury Live. My name is Yawar Manzoor. I'm a JEE Physics expert. Can definitely read it out from the screen itself. Okay. Hi, good evening. And you can basically follow me on Unacademy. This is my username. That's Yawar Manzoor. You can definitely follow me over there. This is my username because we come up with special classes every single time. So definitely you can check that out. Now, apart from this YouTube platform, we teach on Unacademy's own platform. Over there, you can basically take this plus subscription. You can take this iconic subscription. Okay. Because country's top educators are basically teaching you over there. So that's why I suggest you to basically join at least once, download the Unacademy app, have a look who are the teachers who teach you over there. And if you take this plus subscription, you will be basically getting the live classes every single day. You'll be getting this weekly test once you are done with the entire stuff, whatever you have studied for the entire week. Afterwards, you'll be getting the weekly test. You'll be having the structured courses. You'll be getting the unlimited access. Okay. Hi, good evening. What's up? So what's going on? Everybody doing great. And if you take this iconic subscription, you'll be getting this personal guidance. Okay. And you'll be getting all the benefits you get in plus and some of the extra benefits as well. That's this personal guidance, test analysis, experts guidelines, study material, study planners. In this personal guidance, you'll be basically getting the personal mentorship. We'll be helping you throughout your exam, how to crack this exam, how to crack that exam. So that all comes basically under this personal guidance only. And this is what we call the test analysis. After once you are done with your test, afterwards you have to analyze the scores, in what portion you are lagging in what portion you need to score more, so that you'll get the good results in the upcoming mock test or the test. Okay, this is the experts guidelines, study material, study planners, everything. And this unlimited access, you can even create your own batches inside Unacademy. For example, there are 10-15 batches running inside Unacademy. You want to create your own batch of the different of your favorite educators. So definitely you can create in this unlimited access. Fine. Now the point is, for how much amount of time you can take this plus subscription. You can definitely take it for 3 months, 6 months, 12 months, 18 months, and 24 months. Okay. And if you take this for this much of time, you can definitely check the prices exactly over here. But right now the price, I would say the discount is going on. I'll tell you after some time. And even the EMI options are available as well. Okay. EMI options are available as well. You can basically take it. You don't have to pay the entire amount at once. You can pay it every single month. Okay. So if you take this plus subscription for like 12 months, for 18 months, and for 24 months, iconic subscription, not the plus. So the prices are exactly mentioned over here. You can use my code to get the maximum possible discount. This is my code in order to get the maximum possible discount. Now, this is what we call the batches which we have launched recently on Unacademy. Okay, these are the batches which we have recently launched on Unacademy, like 22 yesterday itself. Okay, 22 day before yesterday we launched these batches, and these are the batches in which country's top educators are definitely teaching you. So you can definitely join these batches in order to boost your rank in your upcoming JEEs. Okay. And we have this CBSE plus JEE combo offer right now going on inside Unacademy. If you take that for 12 months, the regular price is basically 52,000. You can basically get afterwards, when you get that much of discount, you'll get it for only 39,780 rupees. Same goes for this 12 months of subscription. You will get it for 56,520 rupees only. So means you are saving 12 months, 12,000 rupees off, and you are saving 21,980 rupees. How you can exactly save this much of money? You can definitely use my code, that is this Yawar. you can definitely use. That is my code. That's this Yawar. Okay. Yeah, I'll be sending the notes in your Telegram group only by today itself. And yeah, I'll be covering the every topic of friction. We are gonna done with this friction by today. Today only. Okay. Chill scenes. And I just need to know who was that guy who felt bad because of me. Give me a thumbs up. I just need to know. And I just want to say sorry to that guy. So definitely you can use my code in order to get the maximum possible discount. Definitely you should go for this one. Understand, prices will rise for sure. This is before price hike. This is after price hike. So go for it as soon as possible. Understand? And this is Unacademy's combat, biggest combat. Understand? Mega combat. Biggest scholarship test for IIT JEE aspirants. If you get the rank from 1 to 3, you'll be getting 100% of scholarship. If you get the rank from 4 to 10, you'll be getting 75% of scholarship. Okay, even you can get up to 4+ crore rupees of scholarship. What you are supposed to do exactly in this? You'll have to basically give a test on 26th of September, 11 a.m. Go for this test. You are the guy, okay? Bhargav. What happened yesterday, day before yesterday? Come on. I just need to know in the live chat what happened that day. Did I say anything wrong? Huh? And this is Yawar. When you basically enroll in this one, you can basically use this code for enrolling. I suggest you to basically go for this one on 26th of September. At least get the free scholarship on Unacademy. Get this plus subscription, iconic subscription by taking this one. Next is you can ask a doubt on Unacademy because we have this beautiful feature on Unacademy. You can even ask unlimited number of doubts. Okay, you can ask the doubt any damn time. You'll get the high quality video solutions. Understand? That too in English as well as in Hindi language. So definitely you should go for this one. So doubts and solutions is the option available over there. Take a picture, upload it on Unacademy. Make sure you crop that particular image. Okay, it's not like you'll send 5 or 10 doubts in one single picture. No, that's not permissible. And you'll get the solution within no time for sure. Okay, these are the do's and don'ts that you need to exactly follow once you go for that. Doubts in this. So first of all, let's talk about this angle of friction. What this angle of friction all about. Come on, can you guys tell me what is this angle of friction in the live chat? I'm not asking about the angle of repose. Okay, angle of friction only. See, let me just make you understand. See, if I say, for example, this is a block over here, fine. This is a block placed on this surface. Understand? So this block is basically placed on this surface. Whenever two bodies come in contact with each other, we say the contact force is basically there. Understand? We say contact force exists there. We have studied this previously in very detail. I'll just tell you once again. So when this body comes in contact with this surface over here, so the charged particles of this surface will apply the force on the charged particles of this body. We have studied this in very detail previously. So we call that force, resultant of all that, those small forces, we call that nothing but contact force. Simply you just remember, when two bodies come in contact with each other, there exists a force. That's what we call the contact force. And it is not necessary that contact force will be always perpendicular to the surface. No, it's not necessary. I'm talking about the contact force. So we have studied previously that contact force can be at some angle. I call, for example, that is something like this. Okay, this is what we call the contact force in that case. Listen to me very carefully. Okay, this is what we call the contact force. Now, we have studied afterwards that this contact force can have two components. The first one will be exactly something like this. Okay, that's perpendicular to this surface, and we call this component as normal force. Understand? And the another component will be exactly that's parallel to this one. That will be something like this. Okay, that will be something like this. Can I just, yes, and we call this as, this is nothing but friction. Previously we have discussed this in very detail. Okay, what exactly I said? This is the contact force. When two bodies come in contact with each other, there is this force. That's what we call the contact force. So this contact force will have two components. The first one is this one. This is the resultant. This is the first one. We say this is what? Perpendicular component, because this is perpendicular to the point of contact. This is the point of contact. So we say this perpendicular component is called perpendicular component of normal force, of contact force, is called normal force. Fine. We have studied this previously in very detail. And the second thing is that this, either you say tangential component or you say polar component. This polar component of contact force is called, that is frictional force, simply you say, okay, frictional force. We have studied this previously in very detail. This polar component or this tangential component of this contact force is nothing but frictional force. Now, what is this angle of friction? Listen to me very carefully. This is the point number one. This is the point number two exactly. Okay. Now, the angle of friction, I'll just write over here. This angle of friction is nothing but is the angle between the contact force and normal reaction. Understand? This is what we call the angle of friction. So what will be the angle of friction over here? This one or this one? That is the angle between this normal force and this contact force. So we can clearly say this is the angle of friction in that case. Okay, fine. So this will be exactly the angle of friction. Now, if I ask you to tell me how we can exactly find this angle of friction, can anybody of you tell me over here how we can exactly find this angle of friction? You will say, sir, it is very simple. Take this vector and place it over here. Understand, this is the polar shifting of vectors. If I say, for example, we can do it. Okay, we have studied this in vectors. So we can do this polar shifting of vectors. We're taking this vector, we are placing it over here. Now, can you tell me in this triangle over here, tan of theta? You'll say, sir, this tan of theta will be nothing but that is this perpendicular upon base. If this is theta, that's perpendicular upon base. Tan theta is nothing but. So can I say in this case, tan of theta is nothing but that is perpendicular upon base. That is this F upon this M. So F upon this N. Fine. Now you just tell me one single fact over here. See, this frictional force is what frictional force? We say the body is about to move. When the body is about to move, in that case, if I, for example, I'm considering that case only. When the body is about to move, in that case, we say basically friction is nothing but that is limiting friction. Okay. When the body is in motion, in that case, we say friction is nothing but kinetic friction. When the body is basically at rest, understand? So we say over there at that point of time, the friction is nothing but static friction. Understand, this we have studied previously. So can I just say this will be FL in that case? 100%. Limiting friction because the body is about to move. So can I just write in this case that is tan of theta is nothing but. So this will be mu S times of exactly N over here upon this N. So this will cancel. So can I just write from this one, this theta will be equal to, that is this tan inverse of this mu S exactly over here. 100% we can definitely write it. Come on. Everybody understood? Everybody got the feel of this one? This is what we call the angle of friction. We're gonna be solving some of the beautiful questions on this one, okay? Now, what is this theta r? This is what we call the angle of repose, okay? Just represent it with this theta r. Understand? Getting me what I'm trying to say? This is the angle between what? This is the angle between this normal force and this contact force. Now let's talk about this angle of repose over here. Everybody? Okay, that's great. So let's talk about this angle of repose over here. Now if I say, for example, this is the block on the inclined plane. Understand? This is some block. I'll just show you. Okay, this is a block on some inclined plane. Okay, can you just see it? Okay, fine. This is the block on inclined plane. Fine. I'll just have to do this experiment over here. That's why. Now see. अरे यार क्या हो रहा है इसको? So this is exactly the block on this inclined plane. I'm asking you one single question exactly. This block is exactly addressed. This theta is exactly very small. Understand? If I say, for example, this is the theta over here. Okay. This is, for example, the theta over here. Understand? This is making the theta with this x-axis. So I'm placing the block on this inclined plane. Now see, theta is very small. Understand? If I keep increasing the theta, still the block is not going down. Understand? Still the block is not sliding. If I keep increasing more theta, still the block is not going down. Now, if I keep increasing, if I more increase this theta, the block will basically start sliding in the downward direction. So can I say that this depends upon this theta exactly over here? 100% it depends upon the theta. So we say when the block, listen to me very carefully, when the block is about to slip, about to slide on an inclination, on an inclined plane, okay, on an inclined plane, we say that angle is nothing but the angle, that angle is called angle of a repose. Okay, you getting me what I'm trying to say? So this is what we call the angle of repose. I'm saying that initially, for example, this block is exactly over here. Okay, so the block is not falling. Understand? It's something like this. Now I increase this theta, still the block is not falling. I increase this theta, still the block is not falling. When I increase more theta, for example, at 31, if I say, for example, at theta r is equal to 30 degrees, at 30 degrees, the block is not falling. Now, if you increase from 30 to 31, once you increase 31 degree, so the block will start skidding. Understand? So means at 30 degrees, the block was not falling, but if you increase theta is equal to 31, the block will start falling. So means at 31 degrees, can I say that the block is about to fall? Afterwards, the block will exactly start falling. So that angle is what we call the angle of a repose, after which the block will exactly start falling in the downward direction, after which the block will start falling on that inclined plane. Everybody understood this one? Any sort of confusion do you have? Okay, this is a very simple concept. Now listen to me very carefully. Listen to me very carefully. I'm saying that over here. Okay, let's understand the physics behind this exactly, how this scene exactly happens. Okay, now could you please tell me what are the forces acting on this block? You'll say, sir, it is very simple. In the downward direction, you will say, sir, that is nothing but mg. This force mg is acting in the downward direction over here towards the center of the earth. Okay, can I say it like that? Yes. So if this mg is acting in the downward direction, can I say over here, this is the normal force acting, because this surface is exactly in contact with this inclined plane. When the two surfaces are in contact with inclined plane, there exists a contact force. So we say over here, this is nothing but normal force. Understand? And there is friction also. The block is about to slide. Understand? The block hasn't slided yet, but this is about to skid. This is about to slide on this inclined plane. So there is a normal force. So friction will also act on this one. So can I say this will be nothing but friction in the upward direction? Okay, between this and between this will be perpendicular and this will be parallel. The skid wants to exactly go down. This has the tendency to do relative motion. So friction will act, that will hold this. So friction is basically holding this block over here. Fine. Now, this mg will have two components. You will say, sir, yes, this mg will definitely have two components. Can I say, if this is theta, can I say this will be nothing but mg cos of theta r, just represented with this theta r. And in that case, this will be nothing but mg, this cos of this theta r, you say simply. Understand? This is mg cos of theta r. Arey yaar, kya likh diya? Sin of theta r. Mg sin of this theta r. Mg sin of this theta r, exactly, if this is theta. So this component, we resolved this mg in two components, this component and this component exactly. Now I am saying that we are discussing that condition. in which, listen to me very carefully, we are discussing that condition in which the block is about to slide. So means block is still at rest. Understand? If the block is still at rest, can I say this force will be equal to this force? If I try to make the FBD of this one, what is the force in the on the right side? You will say sir, F. What is the force acting on the left side? You will say, sir, that is mg sine of this theta. Understand? What is the force from the upper side? You will say, sir, that is nothing but n. And what is the force from this side? Okay, we resolved this mg in two components. Just I'm placing it over here. This will be nothing but mg, that is cos of theta exactly. Okay, this is the FBD. The block is at rest, about to fall, about to skid, but it is still at rest. It is still at rest. Okay. Yes. So it is still at rest. So can I say in that case, this force will be equal to this force 100%. This force will be equal to this force 100%. So I'll just write it over here. So this will be mg sine of theta is nothing but that is this F 100%. And this n will be equal to that is nothing but mg cos of theta 100%. I can call it like that. There is no confusion till here. I hope everything is clear to you people. Okay. So this is the condition. This force is equal to this force is equal to this force. That's why the block is exactly at rest. Now I'm saying that when you keep on increasing this theta, okay, the block will exactly fall. Understand? I told you, I gave you basically the clear experimental view. This is the experimental view. Initially the theta is less. Now if you keep on increasing this theta, this block will exactly fall. This block will exactly start falling. So why is this exactly happening? See, if you keep on increasing this theta, when you increase this theta means this theta will exactly increase. When theta increases means sine of theta increases, because value of sine theta depends upon theta. Understand? So sine theta will increase. So when sine theta will increase, mg sine theta will increase, because this is mg sine of theta. This entire quantity will increase. This entire quantity is nothing but force which is pulling this block in the downward direction, in this direction. When this force will become more than this one, so obviously this will start sliding down. Understand? You getting me what I'm trying to say? So basically this will start sliding down, this will start falling down. So if this increases, obviously mg sine of theta will basically increase in that case. So we say block will slide. Block will slide. Okay, fine. Very simple till here. Yes, this is crystal clear. Okay. So we say basically block will slide in that case. The next thing is, if for example this theta decreases, in that case what happens? You'll say, sir, this mg sine theta will decrease. Theta decreases, sine theta decreases, mg sine theta decreases. In that case, so we say if theta decreases, sine theta decreases, mg sine of theta decreases. Means what can be the least value of this sine of theta? You'll say, sir, 0. When theta is equal to 0 degree, sine 0 is 0. So if I say, for example, this theta is equal to 0 degree, you will say, sir, sine of theta will be in that case 0. Understand? And what happens with the cos? You will say, sir, cos of 0 will increase. Cos of 0 is, it will have maximum value 1. So you'll say, sir, cos of 0 degree will be 1. Understand? Cos 0 is 1. When theta is 0 degree, cos 0 will be exactly 1 in that case. So if cos, when you basically decrease this theta, in that case, can I say this cos theta will increase? If this cos theta increases, this quantity will exactly increase. Can you tell me the frictional force in this case? See, this frictional force, how do we exactly write this friction? We say, sir, this friction is nothing but mu times of n. Understand? Mu s times of n in case of the limiting friction. So you'll say, sir, this F is equal to, what is this mu? What is n in this case over here? You'll say, sir, in this case, this n is nothing but, that is, n is nothing but mg cos of theta. Okay, just write it over here. That is this mg cos of theta exactly. So if theta increases, if theta decreases, means theta is equal to 0. We are decreasing the theta. Understand? So we are decreasing the theta. When theta decreases, cos theta increases. And when cos theta increases, means the mg cos theta increases. Means frictional force will exactly increase, because in this case frictional force is equal to mg cos of theta, mu mg cos of theta. So I would say in that case this frictional force will basically, what happens to this frictional force? This frictional force will basically increase. So that's why in that case, if you basically decrease this theta, the box will not slide, the box will not fall, because the friction will exactly increase in that case. You getting me? If you increase theta, mg sine theta is increased, this is basically being pulled in this direction, and friction is decreasing. Okay, on increasing that one. This is the reverse process. This was basically the physics behind this one. Everybody understood this? Come on, in the live chat. Okay. I hope so. Yeah, that's great. Let's move on to, okay, now we need to find basically what is the angle of this, what is the value of this angle of friction. Okay. So just take this equation number 1. Okay, just take this equation number 1. So we can definitely write it over here. That is from equation 1. So can I just write from this equation 1, that is mg sine of theta is equal to f. So you'll say, sir, mg sine of theta r is equal to, that is nothing but f exactly. Can I just write this mg sine of theta r is nothing but how much is this f exactly in that case? So you'll say the body is about to fall. In that case, we'll say definitely, sir, mu mg cos of theta. You'll say, sir, that is nothing but this mu mg this cos of theta r exactly. Can we just write it like that? Just simply write this is s mu of s, because the body is about to fall in this case. Understand? That's how we exactly define this theta r in that case. Okay, so we got this one exactly over here. So from this, you are supposed to tell me how much will be this theta r exactly. Fine. So this will cancel. Can I just write this is sine theta by cos theta? So this will be sine of this theta r upon this cos of theta r will come out to be, that is nothing but this mu times of s. So further I can simply write this will be how much? This is tan of theta. So this will be tan of this theta r is nothing but mu times of s. So theta r will be exactly tan inverse of this mu times of s exactly. So this is how you can exactly find this, what do we say, angle of repose in case of this inclined plane. So what is the definition of this? Was the physics behind this. How exactly on increasing the theta the block will exactly slide, on decreasing the theta block will not slide because friction will increase. I told you the physics behind that. So now this is basically telling you how you can exactly find this theta r. This is what we call the angle of repose. Okay, angle of repose. So we say this is that angle when the block is about to fall. Understand? If you, for example, increase a bit of a theta from this theta r, the block will basically start falling down. The block will start falling down in that case. It will start skidding. So this was all about it. Let's move on to the 3 cases. Understand? We have this case 3. This is case number 1. This is case 2. And this is case 3 exactly. Understand? Listen to me very carefully. Everybody understood this? And like this video, mark the attendance before you. Okay, come on, everybody of you are supposed to mark the attendance, like the video as soon as possible. Now, so the first condition in this case exactly is that is nothing but theta is, if I say, for example, there is this inclined plane. Okay, there is this inclined plane. I'm placing a box on this inclined plane. Fine. So I'm saying, for example, the angle is basically theta over here. Fine. Now, if I say, what is theta r? Theta r is nothing but angle of repose. Okay. What is that? The angle at which the block is about to fall. Understand? That's what we call the theta r on an inclined plane. Fine. Now, if I say, for example, this theta is less than theta r, means the theta given over here is less than this theta r. Theta r is what? The angle at which the block is about to skid. So can I say in that case, there will be no slipping. The block will not skid. Block will not skid. In that case, the block will not skid in that case. 100% I can say it like that. Theta is less than theta r. Theta is less than theta r in that case. Because this theta r is the maximum value of that angle after which the block will start falling down. So obviously over here, this is saying the theta is obviously less than that. So how will the block exactly skid? So in that case, can I say static friction will act? Static friction will act. Okay. So when this becomes the theta r exactly over here, so the block is about to fall. In that case, what will act? You will say, sir, limiting friction. Because limiting friction is that friction after which the block starts sliding, after which the block starts moving. So that's why we say over here static friction, because theta is obviously less than this one. So obviously here will be less friction will be exactly over here than the limiting friction. So that static friction will be exactly equal to the applied force. We have studied this previously. Static friction is a variable friction, variable force that adjusts its value according to the applied force. We say this static friction will be equal to applied force in that case. Applied force, okay? I hope everything is clear. Everything is clear. Okay. Now, the second point exactly over here is, when theta is greater than this theta r, means this theta is greater than this theta r, this theta. Understand? Theta is greater than theta r. So can I say in that case, what's going to happen? You'll say, sir, theta r is the maximum value of that angle after which the body starts sliding. When this theta increases the value of that, so obviously the block will slide. Obviously the block will slide in that case. So can I say the block will exactly slide in that case, and kinetic friction will act. Kinetic friction will act. Okay, fine. Yes, 100% we can say exactly like that. And what is the value of that? F k is equal to mu k times of n. Fine. Fine. Now, when theta is equal to theta r, when this theta becomes equal to the angle of repose, in that case, the block is about to slide. The block is about to slide. So can I say in that case, body is about to slide, in which limiting friction will act, because limiting friction is that friction after which the body starts moving. Okay. Initially, the body is at rest, means static friction acts. When the body is about to move, in that case, we say limiting friction act. We have studied this in the last lecture. And when the body is in motion, we say kinetic friction acts. Okay. So these are the three cases that you need to exactly keep in your mind. So we have this first question on the screen. I want you people to mark what is the option exactly, A, B, C, D. Come on, in the live chat itself. I need to know what is the correct answer in this one. Okay. Come on, in the live chat. Can you just tell me in this case? This is an inclined plane. Understand, this is an inclined plane over here. 30 degrees. This angle is given as 30 degrees exactly. With the horizontal, the coefficient of sliding friction between this box and the plane, coefficient of sliding friction exactly is given as, that is 0.4. Find the acceleration of a block. This block is basically sliding over here. Can you just tell me? The block is moving in this case. See, whenever you find this mu is only giving, so understand, check from the question whether the block is moving or the block is exactly at rest. If the block is moving, we say kinetic friction will act. At rest, we say static friction will act. If the body is about to move, in that case, limiting friction will act. So understand the question accordingly. So can I say in this case over here, how can we exactly find this one? The first thing that you are supposed to do is, you draw the forces. Okay, what are the forces acting on this one? Then accordingly we will check what's gonna happen in this case. So you'll say, sir, in the downward direction, what is the force acting? You'll say, sir, that is nothing but this mg. Okay. This is this mg. So can I say in this case, if this is mg and in the upward direction, you will say, sir, normal force is acting. When two bodies are in contact with each other, normal force acts. This block is exactly on this surface, so normal force is acting. Fine, that's great. You'll say, sir, in this case, this block is basically sliding on this one, and this is a rough inclined plane. This is a rough inclined plane. So means there is friction available also. So this surface will basically not let this block to go in any direction, in this direction. So friction will basically act. So I would say that friction, if the block is going in this direction, friction will act in the backward direction. I can say that is nothing but this F. Fine. And if we resolve this mg in two components, you'll say, sir, that is nothing but over here. This is mg. This will be mg. This is sine of 30 degrees in this side. And over here, can I say this will be mg. This is cos of 30 degrees, 100%. I can say it like that. Okay. Anybody getting any sort of confusion? I hope no. Now, so we got this one over here. Can you just tell me, if you basically do one thing, so this is the acceleration, I would say something like this. Fine. So can you just tell me over here what's gonna happen in that case? You'll see, sir, sir, just take this block and place it over here. When you place this block over here, in the upward direction, you will say, sir, N is acting. In the downward direction, you will say, sir, this mg cos of this 30 degrees is exactly acting. And in this side, from this side, this is mg sine of 30 degree exactly acting. And from this side, you'll say, sir, friction is acting. And the acceleration is in this direction. Understand? So we can simply use the Newton's second law. Now take the horizontal motion first. So you'll say, sir, by taking the horizontal motion, understand, or take the vertical motion. Sorry, take these vertical forces. Understand? Consider the vertical motion of this one. So that is this N and this one. Can I say in that case, this N will be equal to, that is nothing but mg, this cos of 30 degrees, because cos of 30 degrees, because there is no motion in the vertical direction. Understand? This force will be equal to this force. The block is neither going up nor down. So can I say N will be equal to this mg? 100% we can definitely say it like that. Okay. So definitely we can say it like that. So now in this direction, if we say there is acceleration towards this, so can I say this is mg sine of theta minus this f? Use the Newton's second law. In the second equation, that is this mg, this sine of 30 degrees, this sine of 30 degrees is minus this force, minus this frictional force F, because this is sliding down. So this is becoming less, this is more. So that is nothing but this F is equal to mass times of acceleration exactly. Understand? So this is the scene exactly over here. We are supposed to find the acceleration only. So can I just write this will be exactly mg, this sine of 30 degrees minus this is F is equal to mu times of N. Understand? Can I just write it like that? This will be nothing but this mu times of this N is equal to, that is mass times of acceleration. So this will be mg, that is sine of 30 degrees minus mu of, what is N? N is coming out to be in this case, that is mg cos of 30. You will say, sir, mg. Say, sir, mg. This mg, this cos of 30 degrees is equal to this mass of times of acceleration. M will exactly cancel over here. It says, sir, this acceleration is coming out to be, that is nothing but take this g common, that is cos of sine of this. Very simple. Option D is the correct option. So you'll say, sir, that is this sine of 30 degrees minus this mu cos of 30 degrees exactly. Understand? When you put the values, take g is equal to 10 meter per second square, sine of 31 by 2, root 3 by 2, value of mu is 0.4. So this acceleration will come out to be 1.505 meter per second square. So this is the option D. Okay, very simple question. Everybody, I want all of you to basically solve this one. Okay, let's move on to the next one. Come on. Tell me, how can you exactly solve this question? How can you exactly solve this question? All of you. So over here, this angle is basically given as 45 degrees. This is 45 degrees exactly. This angle is 45 degrees. What you are supposed to find in this case is find the coefficient of sliding friction between the box and inclined plane. Okay, then inclined, there's a box over here sliding on this inclined plane, angle is 45 degrees. You are supposed to tell me what is the coefficient of sliding friction. How much is the coefficient of friction exactly? Not the frictional force. You are supposed to find the mu. Understand? Come on. Can you solve this question? First of all, you draw the forces, and it is saying that a force of 400 Newton acting horizontally pushes the block, 20 kg block placed on this one. Understand? There is a force acting on this one horizontally. That is nothing but 400 Newton. Understand? That's pushing the block. So in that case, we say acceleration is up the plane. So in this case, this will be the acceleration exactly. So this is acceleration exactly. Okay. Theta is equal to 45 degrees with the horizontal, and the acceleration experienced by the block is nothing but that is 0.6 meter per second square. So that is 0.6 meter per second square is coming out to be the acceleration. The coefficient of sliding friction in this case, how can you exactly find this one? This is a very simple question. Okay. How you can exactly solve? Let me just show you. First of all, what do you basically do? Draw the forces. Okay. This will be what? How much is the mass of this one? That is 20. So this will be mg, 20g. So can I just write it 20g 100%? If this is 20g, how much will be this force? You will say, sir, this is nothing but that is 20g. It will be cos of 45 degrees exactly. So can I say in this direction, this will be nothing but that is 20g, that is sine of this 45 degrees exactly. We resolved this in two components. That's 20g cos of 45. This is 20g sine of 45. Okay. These are the two components we resolved exactly over here. What is the next thing that we're going to be doing in this case is that is nothing but two bodies are in contact with each other. We say there is a normal force acting over here. Okay. And this surface is a rough surface. So in that case, friction will also act over here because two bodies come in contact with each other. This is the acceleration. This is pushing the block in this direction. So can I say that this will be exactly the friction in that case over here in this direction, because friction opposes the relative motion. This is trying to go in this direction. This is basically the friction acting in this direction. Can I definitely say it like that? 100% I can say it like that. Now you just tell me one thing. Do one thing. Resolve this also in two components. You'll say, sir, it is very simple. So if we resolve this in two components, can I say that this will be one component and this will be exactly two components, second component? If this is 400, this is 45, can I say this will be also 45? So this will be 400. This will be 400 cos of 45 degrees, and this will be this 400 sine of 45 degrees exactly. Everybody understood till here? This is a very nice question. Okay, everybody understood till here? These are all the forces which are acting on this one. Now you need to exactly solve this. I'll make it very simple over here. I'll just try to show you exactly its FBD. Understand? So we will represent the block as a point mass exactly. I'll just show you its FBD. Okay, this is its FBD exactly. See, this is the block exactly. So can I say in the downward direction, what are the forces acting? This is the first force. You will say, sir, that is nothing but 20g cos of 45 degrees, cos of 45 degrees in that case, 100%. And what else is acting in the downward direction? This one, because this force is also acting on this one. Understand? So I showed it over here because there was no space. So this is acting also in downward direction. That is 400 sine of 45, 400 sine of 45 degrees. Okay, what is the force acting in this direction? You will say, sir, in this direction, first of all, this F is acting, and this another one, that is nothing but 20g sine of 45 is acting in this direction, 100%. What else is acting in this direction? You will say, sir, in this direction, what is the force acting means in this direction? You will say, sir, that is nothing but this 400 cos of 45. That is this 400 cos of 45 degrees. 400 cos of 45 degrees. Cos of 45. I'll just 45 degrees. एक second, I'll just rub it. अच्छा ठीक 400 cos of 45. This is 400 cos of 45, and in the upward direction you will simply say, sir, this force is exactly acting, that is nothing but this normal reaction. Understand? And this is what we call the acceleration in that case. Now can you use the Newton's law in order to solve this one? Understand? We are done with the forces, every damn thing over here. Yes. Okay, getting me what I'm trying to say? If this is the acceleration, can I say this is the net force? So this will be this force minus this force, that will be the net force. First of all, just write upward force will be equal to the downward force because there is no motion in the vertical direction. So this force will be equal to this force. So what are the forces in the upward direction? You will say, sir, the first of all, that is nothing but N is equal to 400 sine of 45 plus 20g sine cos of 45. That is 400 sine of 45 plus this 20g cos of 45, that is 20g, this cos of 45 exactly. I can write it like that. Fine. This is the first thing that we exactly got. Now, in this direction, in the horizontal direction, motion is over there. We say we can use the Newton's second law. Net force is equal to mass times of acceleration. So it says, sir, acceleration in this direction, this force is more than this one. Can I just write in that case, in horizontal direction, use F net is equal to mass times of acceleration. So what is that? That's 400 cos of 45. You can simply say, sir, that is nothing but we can write that is this 400 cos of 45 degrees minus this force minus exactly this force and this force. Can I just write it like that? That is nothing but say, sir, 20g sine of 45 degrees minus This F exactly, that's the frictional force. This force, that is this 400 cos of 45, means this F and this 20g sine of 45, because these are the only forces acting in the left direction. So can I say this will be equal to mass times of acceleration, 100% mass times of acceleration. Mass of this block, net force is equal to mass times of acceleration. 100% I can write it like that. Now the next thing exactly over here is, what is the value of this F? You can simply say, sir, that is mu times of n. So just put it over here. You'll say, sir, that is 400 cos of 45 degrees minus 20g sine of 45 degrees minus F is, that is mu times of n. That is mu times of n. What is the value of n? You will say, sir, that is nothing but this. So this will be this 400, that is sine of 45 degrees, because we already got this. That's plus 20g cos of 45 degrees exactly. Okay. And this will be exactly equal to, that is nothing but a mass times of acceleration. Okay. This is what we exactly got from this one. Just this is the value of acceleration. Now this is 400 cos of 45, 1 by root 2, put it over here. 20, g is 10 meter per second square, 20 into 10, sine of 45, 1 by root 2, put it over here, minus mu. What is the value of mu over here? That we need to exactly calculate. What is the coefficient of sliding friction? 400 sine of 45, 1 by root 2, 20, g is 10, cos of 45, 1 by root 2, is equal to mass of this block, given how much? 20 kgs. So 20, acceleration of this block, 0.6 meter per second square. When you put all of these values over here, you will get the value of this mu. Understand? This mu, calculate this, how much this is coming out to be. Come on, in the live chat. Okay, come on in the live chat. Yes, somebody is saying. Yeah. Ria is saying 0.31. Exactly. So this mu will come out to be 0.313, something like that only. So this is basically the coefficient of sliding friction afterwards. Understand? So what is the first thing exactly this is a very nice question. What is the first thing exactly you did? You placed this box over here. This is the box exactly. You draw all the forces which are acting on the box. Next, it is saying that 400 Newton is external acting on this one. So you resolved this 400 in two components, this component and this component. Then basically you took its vertical motion and then horizontal motion. Balance the forces, apply the Newton's second law, get the answer. Okay. That's great. Okay. Now, this was a good level question. Now we have this very simple question, not that difficult. This was asked in JEE Mains, JEE Mains 2019. JEE Mains 2019. How can we exactly solve this question? Let me just show you exactly. Okay. JEE Mains 2019. This question is having much good level than this one. Okay. This is just nothing. So block, can you just tell me the answer in the live chat? I need to see how can you exactly give me the answer of this question. See, a block of mass 10 kg is placed on a rough inclined plane as shown in figure A. Okay. This one. This is the block A placed on this inclined plane exactly. Force of 3 Newton is applied on the block. 3 Newton is exactly applied on the block in this direction. Understand? The coefficient of static friction between the plane and the block is how much? The coefficient of static friction is given, that is 0.6 exactly. What should be the minimum value of force such that the block does not move downward? Understand? What should be the minimum value of force over here so that the block does not move exactly? So that block will be exactly over here. So we need to basically balance the forces, that's all. Is this given exactly over here? This is supposed to be, for example, this is 45 degrees, okay? This was given exactly, that's 45 degrees, yes. So, what are they saying? In this case, that is nothing but, we don't want this block to basically slide down. What should be the, there is a block placed on this inclined plane, okay? There are 3 Newton forces acting on this inclined plane, on this block. So, the question is asking us, how much should we apply this F so that the block will be exactly at rest? This should not fall down, understand? That's what we are supposed to exactly write in this case. That's what we are supposed to find exactly in this case. Come on, how can you solve this? First of all, the basic thing is we draw the forces acting on the block. What is the force acting on the block? You'll say, sir, in the downward direction, that is nothing but, say, sir, that is nothing but 10G. Can I say this will be nothing but 10G cos of 45 degrees? Why 10G cos of 45? This is 45, this is 10G. This component of this mg, understand, this is mass into acceleration due to gravity. This will be 10G cos of 45. And this will be exactly 10G sine of 45 degrees, 100%. I can show it like that. Fine. And what is the force acting in upward direction? You will say, sir, the force acting in upward direction is nothing but that is this normal force. Understand, because the two bodies are in contact with each other. You'll say, sir, there is one more force acting over here. I'm saying which one? You are saying this block is in contact with this one. This is a rough inclined surface. So friction will exactly act. So can I say that friction will be exactly this one? Fine. So this is the friction that will exactly act over here. Now tell me. Now just balance the forces, that's all. It's saying that what should be the minimum value of force such that the block does not move. So block has to be exactly at rest. If the block has to be at rest, can I say this force is equal to this force, these forces are equal to this force? If I just try to make its FBD, you'll say, sir, that is simple. In the upward direction, only N is acting. In the downward direction, what is the force acting? We resolve this in two components. That's 10G cos of 45 degrees in that case. And what else is the force acting on this one? You'll say, sir, in this direction over here, that is the force acting, this 3 Newton, and this is acting, that is 10G sine of 45, 10G sine of 45 degrees in that case. What is the force acting in this direction? You'll say, sir, that is nothing but, first of all, this external force F, and this F exactly, that is nothing but frictional force. Now, could you please balance the forces over here? Yes, you can definitely balance the forces. You'll say, sir, in this case, can I just write this N is equal to, this N is equal, upward force equal to downward force, that is 10G cos of 45 degrees, 100%. I can say it like that, okay? 10G cos of 45. And what about these forces? You will say, sir, this plus this, that is F plus this frictional force, F plus this F is equal to this 3 plus this 10G sine of 45, 3 plus 10G sine of 45 degrees in that case. Can I just say it like that? 100%. I can definitely write it like that. Now, what is this F? We say this F is nothing but, that is mu times of what? Mu times of N. We say this is mu times of N exactly. Can we just write it like that? 100%. Come on, in the live chat, if you're understanding this one, do let me know. Okay? Keep this thing in your mind. This is what? Static friction. Understand? Because the body is about to fall. We are supposed to save the body over here from the falling. So just put it over here. You'll say, sir, this F is plus, that is mu times of this N. Instead of this, I'm just writing this. Mu times of N. N is what? That is 10G cos of 45 degrees is equal to 3 plus this 10G sine of 45 degrees exactly. I can definitely write it like that. 100%. So can I just write this will be F plus, we are supposed to calculate this F only. How much should be this force? You'll say, sir, mu is how much? That is 0.6. Can I just write 6 by 10 exactly over here? Multiplied by this 10, multiplied by this G is, take G is as 10 meter per second square. So this is 10 cos 45, 1 by root 2 is equal to 3 plus 10 multiplied by, take G as 10 and this as 1 by root 2 exactly. Fine, this is the scene happening over here. 100%. Okay. Yay. Yes, A is the correct answer. So this will cancel. So you'll say, sir, 6 into 10, that is 60 by root 2. F plus, that is 60 by root 2 exactly. This will be equals to, that is 10 into 10, 100 by root 2. 3 plus 100 by root 2 exactly. Do I have one more slide? Yes, I do have. So just take it over here. So you'll simply say, sir, this F will come out to be, that is 3 plus 100 by root 2 minus 60 by root 2. That is 3 plus 100 by root 2 minus 60 by root 2. So this will be F is equal to 3 plus, this is 40 by root 2. It will come out to be exactly, that is 31 newtons. So option A is the correct option in that case. Fine. Fine, everybody. The because this is the limiting friction acting over here. Okay, it is saying that the block, we are supposed to save the block from falling. Understand? If I say, for example, this is the block over here. Okay, MDR, if I say, for example, the block over here, fine. So I am pulling this block in this direction. I'm pushing this block. For example, I am basically pushing this block with a force F. The block is not moving, but I increase the force. And I made the value, and after which the block is about to move. In that case, this body has the tendency to move in this direction. So friction will act in the backward direction. So I would say this one, opposite to the relative motion. Friction is something which opposes the relative motion. In this case, the block has the tendency to go in this direction. So we are applying the force to save this one. Understand, in this one. So we don't have to basically check. We don't have to draw the direction of friction according to this force, according to the relative motion. The block has the tendency to go in this direction. So friction will try to save this block. So that's why friction will act in the upward direction. So next question. So we have this 2 blocks on an inclined plane. Okay. 2 blocks on an inclined plane. Listen to me very carefully now. If I say, for example, this is a block 1 and this is block 2. Understand, mass of this block is M1, mass of this block is M2. Okay, these are the 2 blocks placed on an inclined plane over here. If I say, for example, this angle is theta exactly. So we are basically going to discuss different cases, what's gonna happen in this scenario. Previously, we were dealing with the blocks only in which there was only 1 block placed over here and that was sliding. What if I say I'm placing the 2 blocks side by side? Mass of this is M1, mass of this is M2. You'll say, sir, first of all, there will act the normal force between these two also, because when 2 bodies are in contact with each other, there exists a normal force. This is the normal force. This is the block applying the normal force on this one. This normal force is acting on this one by this block. Okay, we can definitely say it like that. Another normal force will be something like this. You'll say, sir, that can be something like this, that can be something like this. Okay, this is the normal force on this one, understand? These will be different and these will be exactly same. I hope your basics is clear. Now listen to me very carefully. This is the coefficient of friction of this block between the surface and this block. This is the coefficient of friction between this block and this surface, mu1, mu2. Understand, because blocks are different, and over here, that's why the 2 surfaces in both the cases are different. That's why mu1, mu2. Mass is M1, M2. So first case, if I say, for example, mu1 is equal to mu2, understand? So if this case happens that this mu2, coefficient of this friction, becomes equal to the coefficient of this friction. So in that case, we say this normal reaction becomes 0. This normal reaction becomes 0. It's one and there. It's clear, okay? You just try to feel it. So see, if, for example, this coefficient of friction becomes equal to the coefficient of friction and they start sliding, you just try to understand it like this. They start sliding in the downward direction, understand? So what is the force acting on both of these 2 masses? You'll say, sir, that is mg sine of theta in the downward direction. So how much is the friction acting between this and this from this in the below the surface over here between these 2? You'll say, sir, that is nothing but mu n. And over here, that will be mu n in that case. So when the coefficient of static friction in this case and in this case becomes 0, so they will only touch each other, but they will not push each other. Understand? In the next case, you'll get the feel of this one, how exactly. So for now, you just remember it like this, okay? So we say basically these two blocks will touch each other, but no push. Okay, but they will not push. Just write the correct English. But they will not push exactly. Understand? This happens. Okay, this is the scene. What's gonna happen in that case? When this becomes equal to this one, they'll slide exactly over here. Coefficient of friction becomes same, so they will be in touch with each other, but no friction will but no push will be. This will not push this one, this will not push one. That's why we say normal reaction becomes 0. Next cases, you'll get the feel of this one with the next case. If I say, for example, this mu1 is greater than, if this mu1 is less than this mu2. If I say this mu1 is less than this mu2, in that case, what's gonna happen? Okay, forget about this case. Let's talk about the case number 3 first, okay? And see, in first case, we have to basically show that acceleration also. Could you please tell me how much will be the acceleration in this case? You'll say, sir, if I take, for example, both of these blocks, in that case, you'll say, sir, acceleration will be what? You'll say, sir, in this downward direction, this is the mg acting, and this will be how much? This will be mg sine of theta in this case, okay? If this is the mg sine of theta, friction will act in the backward direction in that case. So can you just tell me how much will be this acceleration over there? You'll say, sir, that will be this acceleration will be something like, or apply the Newton's second law in vertical, in this horizontal motion. I have told you previously, that is this net force mg sine of theta minus, in that case, that will be this F, that is friction is acting in upward direction. F is equal to mass times of acceleration in that case. So can you tell me this friction? You'll say, sir, this mg sine of theta minus mu times of n. Mu times of n. And what is the value of this n? That will be, this is mg, this will be mg cos of theta in that case. You'll say, sir, this mu, that will be n. Instead of this n is equal to mg cos of theta, that is mg, this cos of theta is equal to, that is ma. This will exactly cancel. So can I just write a is nothing but g sine of theta minus mu g cos of theta exactly. So this came out to be the acceleration of the first block. Understand, if I am taking only one block. So what is this? A1 is equal to, this a is coming out to be, for example, if I say a1, g sine of theta mu g cos of theta. You tell me one thing, same g is for this block also, for this block also. So can I say g is same for both? 100%. Sine of theta, theta is both for same for this one, for this one. So sine theta will be for same this one, for this one also. And we are saying that the condition is mu1 is equal to mu2. So if mu1 is equal to mu2, so this will be also same for both. So can I say acceleration of first block will be equal to the acceleration of second block, because everything is same. So a1 is equal to a2 g sine of theta minus mu g cos of theta. G sine of theta minus mu g cos of theta. Come on, you got it, man? Okay. I hope you got this one. Fine. So this is the case number 3. Afterwards, we'll discuss the case number 2. So when mu1 is greater than mu2, when this mu1 becomes greater than mu2, in that case, what's going to happen? You will say, sir, friction over here will be more, understand? And over here will be less. When friction over here will be more, so the upward force will be in that case more. And in this case, upward force, this is the force F1. And if I say, for example, this is F2. So in that case, this frictional force will be more and this frictional force will be less. If this is more, so this will be basically, this will have less motion in the downward direction, because this force is more in the upward direction, understand? So, and there will be, this friction is basically less, so this will slide very fastly, because on smooth surfaces, the blocks slide very fastly. So in that case, they will hit each other. This block will push this one. This is moving slowly, this is moving fastly. So obviously they will hit each other. This is the first block, understand? Friction is more over here, so this will move slowly, understand, because friction is over there in the upward direction. This is the another block. Friction is less between this block and the surface. So this will move very, very fastly as compared to this block. So this will hit this block. So this will push. So in that case, n is not equal to 0. N will act, understand, in that case. And we say in that case, acceleration of 1 will be equal to the acceleration of 2. You'll say, sir, how? In that case also, acceleration of this block will be equal to acceleration of this block. If I give you the simple example that I have told you previously. For example, this is the block 1, this is the block 2. You are pulling this block in the outward direction with the force F. These two blocks are connected by a string. This is an inextensible string, understand? Or for example, don't take this example, just take this. This is the another block, okay? You are basically pulling this block in this direction. Understand? They are stick to each other. You are pushing this block, okay? This is the force acting. So if you are pushing this block in this direction, so this system will have acceleration, I call it A. So the same acceleration this block will be having, this block will be having the same acceleration. Why? Because they are stick to each other, understand? So this, if this moves, if the entire system moves by 5 meters, this will also move by 5 meters, this will also move by 5 meters. Understand? That's why same is the case over here. When they are stick to each other, the entire system, if it will be having acceleration A, so this block as well as this block, they both will be having the same acceleration A. I hope this is getting clear, okay? So that's why. Now you just tell me one thing. In the second case, if I say, for example, in the second case, listen to me very carefully. In the second case, mu1 is less than mu2. This mu1 is less than this mu2. Means this will move very fastly because friction is less. Over here, friction is more. So it will take time in going down. So they will separate. So in this case, blocks will separate and move separately. Understand? So this is gonna happen. So in that case, we say this will be having different acceleration. G sine of theta means mu1 g cos of theta. Previous case, in the case number 1, this mu was basically same. That's why it was mu only. So over here, mu is different. Mu is different. Acceleration depends upon g sine theta, g cos theta. That will be same for both. G is same for both. Cos theta, sine theta is same for both. So mu will be different. So for this first block, it will be mu1. For second block, it will be mu2. Come on, you got the feel of this one. I need to know, man. Watch this once again, okay? This is a very, very important, okay? From the competition point of view. Now we have this over here. Can you tell me the acceleration of this block? You consider this. This is the block 1, this is the block 2. They are exactly moving together. If these two blocks are exactly moving together, can I say in that case, acceleration in this case will be nothing but, that is how much? We'll say net pulling force. That is how much? Can you tell me? We are supposed to find the acceleration or the force in this case. We are supposed to find the acceleration in this case. So can you tell me, can I just write exactly in this case? This will be something like this only. Huh? Acceleration by using the previous formula. By using the same approach, we are supposed to find exactly in this case, okay? A1 will be equal to A2 in this case. Why? If I, for example, say this is having the acceleration A1, this is having the acceleration A2. A1 will be equal to A2 will be equal to A in this case because they are stick to each other. Why they are stick to each other? Because in this case, we say this mu1 is greater than this mu2. If mu1 is greater than mu2, because then this will move slowly, this will move fastly. This is having less friction, it's having more friction. So they will hit each other. This block will hit this block. So that's why in that case over here, normal reaction will also act between these two blocks. We are supposed to find that also. Okay. Or simply you can definitely use this formula directly over here. What is the force acting in the downward direction over here? You will say, sir, that is, if I, for example, replace this with this, understand? It is something like this. This is a block. They are stick to each other. This is 1 kg, 2 kg. So I'll just write 3 kgs over here. Okay. So I'm saying that over here friction is F1. Why friction is different? Because mu is different. Over here friction is F2. So friction is exactly different in both the cases. So can I say I'll just represent that friction over here? That will be something like F1 plus F2 exactly. F1 plus F2 exactly. Fine. This is F1. This is F2 exactly. So this is the case. Can you just tell me, and what is the force acting in downward direction? You will say, sir, the force, this is mg, and in this direction, the force acting, that will be mg, that is 3g sine of 37 degrees exactly. 3g sine of 37 degrees exactly. So we can simply write, sir, this acceleration is nothing but, or simply just write this one. That is, apply the Newton's second law in this case. You will say, sir, this force, net force is equal to mass times of acceleration. This force minus this force. That's 3g sine of 37 degrees minus F1 plus F2. Understand? This force exactly. Can I just write it like that? Is equal to mass times of acceleration. How much is the mass? That is 3 exactly. That is 3a. That is nothing but 3. Acceleration is basically a. So how much will be this acceleration? That is nothing but 3g. This will be sine of 37 minus this will be F1 plus this F2 exactly. Fine. So this came out to be the acceleration. When you put the values, you will exactly get. So 3 into 10, sine 37, get the value of sine 37 from this angle. This is 37-degree triangle. This is 3, this is 4, and this is 5. So sine 37, get from this one. This 3 by 5, it will be 3 by 5. Find the F1. In this case, find F1 in this case. Mu is given, mu is given. F1 is what? That is mu1 of n exactly. Find the normal reaction. F2 is mu2 of n exactly. This normal reaction. Just put it in the value. Put it in this one, you will get the value of this one. Okay? Very simple. Similarly, you can find the normal force between this and this also. In that case, you need to take only one block, okay? This I want you people to do by yourself. Let's move on to the last part of this lecture. That is nothing but this. Block on block problems, okay? No, no, no. The topic is not tough. This is basically JEE mains and advanced level. That's why you feel it a bit tougher. Okay. So now, over here, block on block problems. Now we need to basically talk about this one. What is this block on block problems? Okay. So this is force exactly. This is the block first. This is the another block. There is this block and another block is basically placed on this first block. Understand, this is the scenario that's given exactly over here. Now, what can be the conditions in this case? Previously, it was on inclined surface. We don't have to talk about that stuff right now. So this is the block, and on this block, there is another block. Two conditions can exactly occur. First one is both the blocks move together with the same acceleration. Either both the blocks will move with the same acceleration. For example, we are pulling this lower block with a force F. So what's going to happen? This block, if I say, for example, this block is stick to this block, so both will move with the same acceleration. The entire system will move with the same acceleration. Second thing, what can happen? Lower block moves faster, this can move faster, and this can fall down. Or what is going to happen? Upper block will not accelerate. That will, okay. Now, next thing is, this can move basically faster and this will fall down, or this will be having more acceleration as compared to this one. First thing, what's going to happen? See, if, for example, this is a block and this is a block, there is this block placed on this larger block. We are pulling this block with a force F. What's going to happen? Either both the blocks will move together with the same acceleration. Next thing, either this can fall down and this will move faster. Third thing will happen, this will move faster, this will move basically slowly as compared to this block. These are the three things that can exactly happen. Okay. Okay, now see. Tell me in this case, I'll just show you this. This is from JEE 2021. This is the problem. I'll just make you understand this concept with the problem itself. JEE 2021 just was asked in, okay, July attempt, recent July attempt. Let me just show you over here. It is saying that, for example, this is a block F. Understand, listen to me very carefully. If I say, for example, this is a larger block, I am pulling this block with a force F. Understand, what should be the maximum value of this force applied on this M block so that both blocks will move together? Understand, this should not fall down. Both should have the same acceleration. In that case, how we are going to solve this question? Listen to me very carefully. Understand? Now see, if, for example, I am pulling this block in a forward direction, understand, and I am assuming that both the blocks are moving together. Understand condition number one in the previous case. So this is saying that question is saying that both the blocks should exactly move together. If I say, for example, I'm pulling this block with a F force in the forward direction, which force is basically acting on this? Which force is basically pulling this block in a forward direction? You are saying this F. No, this F is acting on the larger block. If I say, for example, the person is exactly over here, this person will see this block as well as this block, both are going together with the same acceleration. But this force is acting on this one. So who is pulling this block in the forward direction? This person is saying, I can see that this M is also moving in the forward direction with the same acceleration. Now see, it is something like this that I have told you previously. If, for example, this is a block and this is a string between these two blocks, this is the another block. If you are pulling this block in a forward direction, this block is also moving, string is inextensible. Now tell me, which force is pulling this block? This force? No, this force is acting on this one. So what is the force that is basically pulling that block? You will say, sir, that is nothing but this force, that is tension, internal force in this case. So this is the force that is pulling this block. If I ask you how much is this force, you will say, sir, it is very simple. Mass of this is M T is equal to mass times of acceleration. Previously, I have told you in the first lecture of Newton's laws of motion. Okay. So you are saying, sir, how much will be this acceleration? Acceleration will be same as the acceleration of this one. Both will have same acceleration. Even the entire system will have same acceleration because they are connected to each other. String is inextensible. If you pull this system, it will displace by 3 meters. This will also displace by 3 meters. This will also be displaced by 3 meters. So they will have the same acceleration also. Now it is something similar to this one. Let me just make you understand. I'm pulling this block in this direction. There is no friction over here. We say no friction. Exactly. There is no friction. Now, in this case, there is friction. Understand? Between this block and this block, there is friction. That is nothing but 3 by 7. Understand? This block and this block. Now, if, for example, you are pulling this block in a forward direction. So, look at this block. With respect to this block is trying to go in a backward direction because this is basically moving in a forward direction. So, if there is a person over here, he can clearly see that I'm moving in a forward direction. This will try to move in a backward direction. But there exists a friction between these two. If this is having the tendency to go in a backward direction, friction will act in a forward direction. I call that F. That friction will pull this block in the forward direction. Can I say it like that? It is something like this only, the internal force, 100%. 100% I can say it like that only. Okay. So now, if this is a force that's acting on this block, that's pulling this block in a forward direction. Now, can you tell me how much will be this force exactly over here? You will say, sir, that is simple. This friction will be equal to how much? In the previous case, tension is equal to mass times of acceleration because this is responsible for the creating this acceleration. You will say, sir, that is nothing but mass times of acceleration, this friction. Now, what is this friction exactly equal to? What is the formula for friction? You'll say, sir, this friction is also equal to, that is mu times of, that is N. Over here, this is mu times of, this is N. So this will be nothing but that is M into A exactly. I can write it like this. Now, could you please tell me the acceleration? You'll say, sir, both the blocks are moving together. The acceleration of the entire system is same. The acceleration of this block is equal to the acceleration of this block. Yes. So can I say that that acceleration I can exactly found? This acceleration will be nothing but net pulling force. Like previously we have calculated this. Net pulling force is how much? This F. Don't consider this also because this is the internal force between this and this. This is the external force, net pulling force. So that is nothing but net pulling force upon net mass. So how much is net pulling force? You will say, sir, that is nothing but this F upon how much is net mass? You will say, sir, how much is net mass? That is this plus this. You will say, sir, this plus this. M plus this M exactly. Just put it over here. So this mu times of N will be equal to, that is M into, how much is this? F upon. How much is M plus M? M is 0.5. This is 4.5. So it will come out to be 5. Understand? 0.5 plus 4.5. It will be 5 only. So this mu is 3 by 7. This is 3 by 7. And this N is, we can definitely write this N as, that is mg. Why this N as mg? N is this normal force. Understand? So this normal force is M into G. So definitely we can write it like that only. So it will be mg is equal to this M F by 5. This will cancel. So F will be 3 into 5. That is this 15 by 7 into this will be, take G is 9.8. That is 9.8 exactly will be F. So F will come out to be exactly, that is 21 newtons. Okay, option number C. Okay, so we need to apply 21 newtons in order to pull this system so that they will move together. The acceleration will be same, so that this will not fall behind. So this is basically, this was, I made you understand this scenario exactly. This was directly from the problem itself. Okay, thank you so much. Thank you. Okay, special class at A at 7 p.m. Take a chill pill. You can definitely follow me on Unacademy. This is my username over there. This is my username on Unacademy. You can definitely check it out on Unacademy itself, okay? And ladies and gentlemen, boys and girls, yes, already done with that. So you can definitely, apart from this YouTube platform, we teach on Unacademy's own platform where country's top educators are definitely teaching you. So if you people want to learn from those top educators, you need to take this plus subscription, or you can take this Iconic subscription. Understand? In this plus subscription, you'll be getting live classes, you'll be getting weekly tests every single day, structured courses, unlimited access, you'll be getting the test analysis. Understand this? See, what the structured courses is all about means these courses have been designed by the country's top educators, okay? कश्मीर में हम यहाँ रहते हैं, okay? And this is unlimited access. Even you can watch anybody's lecture any damn time. That's what we call the unlimited access. You can create your own batches inside Unacademy. Even you can select the different favorite teachers from the different batches itself, okay? Create your own batch, you will have that unlimited access. So this is personal guidance. This all comes under Iconic subscription. Everything basically, all these benefits you get in this plus, as well as in all the benefits you get in this Iconic subscription, like all the benefits you get in plus, okay? And this is the personal mentorship, okay? Thank you so much, man. Where are you from? Where do you live? This is a personal guidance, that's personal mentorship. And this test analysis, experts, guidelines, study material, study planners. You'll be getting a personal mentor who will be guiding you throughout. Okay. He'll be guiding you throughout your exam. And this test analysis is basically what? This test analysis is, once you're done with your test, afterwards you'll have to analyze your scores, in what portion you are lagging in, and what portion you need to work more. That comes under the test analysis. And this is the experts guidelines, study material, study planners. Next we have, you can take this plus subscription for 3 months, 6 months, 12 months, 18 months, and 24 months, okay? By using this code, you can get the maximum possible discount. This is the code. You can get the maximum possible discount over here, okay? Check this one. And EMI options are also available. You don't have to pay the entire amount at once. And you can take this Iconic subscription for 12 months, for 18 months, for 24 months, okay? You can use this code in order to get the maximum possible discount. Use this code Yawar. Next thing is, we have launched these batches recently on Unacademy, in which country's top educators are teaching you for sure, okay? So the prices will rise once again. I want you people to basically, this is Yawar, okay? Use Yawar. This is before price hike, and this is after price hike. This is before price hike, this is after price hike. This is after price hike, before price hike. Now see, if you people want to learn free for Unacademy, from Unacademy, you can definitely enroll in the scholarship test. Understand, you can win up to 4 crore plus scholarship. At least you should basically go for this test. This will be on 26th of September, 11 a.m. Enroll in this one. Link is in the description below. It will ask for a code while enrolling. Use this code Yawar. Understand? This is the code. And you can, if you get the rank from 1 to 3, you'll be getting 100% of scholarship. Go for this one, I suggest you. This is the CBSE plus JEE combo offer. That is for 12 months, for 24 months. This is the discounted price. This is the discounted price for 12. You can save 12,000, and this will be 22,000 exactly. We have this beautiful feature on Unacademy, that's Ask a Doubt. If you have any sort of doubt, you can ask You can ask even unlimited number of doubts. Ask the doubt any damn time. Get the high quality solutions, that too in English as well as Hindi language. You'll receive the exact match of the questions for sure. Okay. This is how you need to exactly ask that doubt. Make sure the picture is not blurred and you need to crop that particular doubt. Okay. Thank you so much. Thank you so much, ladies and gentlemen. Subscribe to this channel, hit the bell notification, like, share, and subscribe. It was really nice interacting with you.